obviously. Okay, the view is to the southwest. I'm northeast of the updraft base. You see how perfectly round the base of the storm is. The Volt region is in here, the apparent clear area, which is probably full of hail and precip I'm getting on me. Remember, those mid-level winds weren't pushing it very fast, so it's kind of not wanting to lift over that warm front. And the warm front it's sitting on, getting easterly low-level winds and southeasterly low-level winds off the deck a bit, feeding into the storm and busting up through there, dumping tons of rain over here. And I sit here for, it's almost 2 hours. The storm kind of sits there and just doesn't go anywhere. And sometimes it'll go back, and then it'll form east. And then when it finally produces a tornado, it was when that hook comes flying east hard. And there'll be some little wispy tornadoes in here. But anyway, just think about the setup. 25 knot flow of mid-level, 18,000 feet or so. Isn't pushing it along very much, but as it's higher, the updraft's higher up, the precip's getting vented. The updraft's tower's leaning, and the precip's getting vented far enough away from the base that most of the cold air is staying away from where the base is, and all the good air keeps feeding into it. It's got uncontaminated air, just perfect air coming into the base. I can't do a whole hell of a lot about these power lines. About the plant one. I want to note a couple things right now. First off, the focus. This was a new video camera this year, and it doesn't have an infinity lock button. And what was happened to me on the first few chases was I didn't know that when I would switch back to auto exposure mode, it would change the autofocus back to turning the autofocus on, because I would have it off. And then there was an infinity setting in there too in the modes. And when I would set that, I didn't know it was resetting that. It was just weird. It took me forever before I finally got it to where I had the focus for sure off from autofocus. So if you see any jumps, it's the autofocus. It wasn't supposed to be on. But storm-wise, you can see it's nice and round. It's got this lowering. And what can happen is that low-level shear will often pick up towards when the sun lowers and you get the stronger low-level flow picking up, usually from that vertical mixing letting up and the low-level winds off the deck picking up, because there's less and less friction when that low-level mixing is going down, like the low-level jet that picks up at night. A lot of times the low-level flow will pick up during that point, and it'll help spin the storm faster. So sometimes before then, the shear isn't quite strong enough down low to get the tornadoes down and going. And the other thing that often happens, if it's not getting vented well enough, say you got a big plume that comes up, and it gets the storm kicked and spinning in an RFD harder, it's like as soon as that plume does that, it's starting this spin. But as its precip comes out, the precip comes down, and sometimes that cold air can get wedged underneath there and just knock the lowered rotation out. Where if you get that, you want that to be upright. You don't want a bunch of cold air getting shoved underneath it. And that's what happens, I think, on this one, is it's just not enough strong low-level flow into it yet, or else it's not vented well enough, or plus it's not moving either, so it's not moving into the low-level flow. So it needs stronger low-level winds. But you can see it does this quite a while. It'll keep rotating and try and get one down, and then it just struggles for quite a while until that one push it comes around. I can't hold this still enough in here, but you can totally see that bolt the edge of the updraft just going around. these supercells will go on cycles like this, where now you can see the area in here just it's got this scuddy, pushed out, detached look. It doesn't go around. But these clouds back here, they just look cold and stable. You know that go at it back there is kind of done when that happens. Usually, you might get some long elongated rope thing that happens, but usually when it looks like that back there, it's done. You got to depend on the next cycle that happens out here, because your new plume, it's probably the new plume goes up, new big rush of updraft fires on the flanking line out here, feeds into where the old one was. That's how it works. Goes up there and rains. New one goes up and rains, rotates around. So sometimes you get the next one that goes up real hard, and it just makes everything want to suck in more air, and you get a better area going here again. And you got to depend on this new area to do better than the first one did. Cycle a new area in the middle. See it getting fatter. This thing is just slowly lifting due north. You could probably tornado if it would turn right, and it's starting to wrap another deal. It's tempted to drive west into that wall area and look more south at that. Battery problems, I have to stop for a while. Here's what's happening here. Remember, the base is over there to the left, the supercell base. Now, there was a big clear area here before. Well, this looks like a new base, but really it's not. What happens is your updraft can rain into a new area, and a whole bunch of cold air can come down or come out, and it just forms a cloud. That's all that's happened here in this area. It looks like it's just a big base, but there's no updraft above it. It's just a thin layer of clouds. And it doesn't mean a whole lot, but it's hard to know if there's new updrafts above here. And also on this point, what some storms will do is think of that supercell as a low pressure system. Just its own little low going this way. And you'll have a warm front with the low, and then the dry line arc. So you got the supercell. And then where the rain is, you got the sort of warm front thing. Well, what can happen with some of these storms is that warm front could be a new area where new bases take over, and you could be chasing, and you're in the southwest part, and you think you don't realize what's happening, but all of a sudden a new updraft's forming, like here. Like if a new updraft was forming above this, you had enough push, and it's just the way it cycled, and you got a new updraft. It can all quickly change and take over and leap ahead on you. It happens sometimes. It happens fairly often, actually, but it wasn't happening now. But if it was, you'd have big updrafts up here, and that back area would kind of be weakening, and all of a sudden this would be looking meaner and meaner and meaner, and then it would start to get its own horseshoe to it. And then next thing you know, this storm has moved east. There's a whole new updraft area formed out there. I'm going to stop and see what it does. It's 6:55. I'm same exact spot. One of the slowest moving storms ever. I don't know if it's ever going to do much more than those little brief thingies. A real sharp uptick in lightning frequency can indicate a very powerful updrafts happening. Actually, that's what's really likely happening. So if you get a real uptick in lightning, you can imagine there's probably a big updraft firing up here now, which is probably what was going on. Think about your structure around updraft base and the flanking line going that way. So all the new updraft towers out here on that flanking line and bigger feeding up into this and dumping out here. If you have a new vigorous updraft exploding now, aloft and just continuing, and it starts putting down lightning down here, that big, powerful updraft plume might suck up more warm, good air and really get the thing going. Because a whole, think of all that power going up. You're going to draw in more air, and the thing just cranks. That's probably what happens, because it's pretty good timing of when it finally does this big tornado in this crazy CG barrage of lightning that's about to happen. Lightning barrage might be starting. Oh, cool. Yeah. Starting to see the structure now that that band's getting out of here. Should be able to really visualize this whole updraft. Well, the lower portion anyway. Look, your whole base was over there and it's leaning to the north. And this is nothing. This goes up way higher and it's a lot wider. Think of that. Think of that going up for miles this direction and being blown. All your rain's blowing out there. Good inflow. Thing just starting to spin. You can imagine now with all this lightning, there's just a bigger updraft going up, and it's almost on its own, changing this whole environment. You can see how the whole thing seems to be spinning more, even in this area, but it still ain't quite ready yet. It's just like, you can almost tell that the low-level winds are just picking up as we get into the evening now. And as that happens, it just gets fed better and better inflow because it's stronger, it's feeding it more unstable low-level air. And it tries to get going this time, but it takes a little bit more, but you can tell it just cycles and ramps up. There's a little crapper shower about to go flying into this thing. Right to touch the camera. South of it. I'm going to try and reform right. Oh man, hell, the thing's going to sit here forever. I think I'll go sample the core, see what it's got. I know the tour groups went west. There might be a tornado back there, but I don't know that you're going to see it any better. This storm just does not move. You can see the bases merging together down there. what happens is this old area off to the right just kind of goes up there and dies, kind of wraps up and gets detached and dies. And then probably this space back here, and then this sort of thing merging into it. There's probably a big updraft right here. But this whole thing takes over, and that's when that radar loops forward, when that big hook happens and goes looping forward. You can kind of imagine how that happens with this new base out here forming. This thing forms on the front of the storm and then just wraps itself up in a hurry. So that moves it east. That's why the hook moves east kind of quickly, as the whole storm just jumps east with this new development. But you'll see how fast this happens. When I come back out of playing with the hail, it's already going to produce this big tornado. Hopefully it doesn't go blah real quick. The icon says 2 1/4, but you know how those go. Could be 5 inch, could be 1 inch. Hopefully my spot is still there when I get back. Going back east, the structure is probably ridiculous right now. That's looking southwest. Glad I didn't go too far into the hill and play around for too long, because it's really apparent now what's about to happen. As soon as I'm looking back there, I could almost know it's going into tornado. You can just tell by how horseshoe shaped the storm base is now, in that RFD notch in here. And just the way it's round, and then how this is, it's straight, it's not being pushed under, it's pretty balanced looking. But then this notch right there, that you could tell it's like a coil. The whole base comes around and then around again inside there, where the dry air's cutting out even further inside there. You can tell, oh, it's probably going to tornado now. And it's probably doing it because that new plume, that new updraft that went up on the base on the southeast side, plus the increasing low-level winds into the evening now, really helped this to just wrap up hard. Goes crazy now. Wow. I'm exactly where I was earlier, just go back here. Now, a few things to note quickly here. This is looking southwest, but basically just south of the tornado here. They'll really have sinking air on the south side of them like this, and then probably rising air on the north side. You can almost visualize that on a lot of tornadoes. You'll see the motion going more down on this side, plowing forward, and then going backwards. And you think about going forward, the wind on the south side would be stronger than on the north side. Though, of course, if they're real strong, it's not like that matters much in the first place. But anyway, you imagine how it's just almost like a propagating thing. You can think about it that way. But now think about that structure again. That big horseshoe shape goes way off to the left and around. And then there's that part cutting in front of the tornado here. But think about that base coming around, coming back around, and then back in here. You have this big coil. That's always where the tornadoes really form, back in that same area. So when you're watching storms, if you can see that supercell rounded base, it's always pretty obvious where the tornado would be if it's going to happen. $725. Big storm. You notice on this tornado, much like the Bowdle tornado, is doing that centering thing where it's hooking around. It's not going the same direction. Kind of going to balance itself out underneath the big vortex aloft. This is just a lower part of it, you know. This is kind of balancing itself out underneath that as that RFD cuts in and cuts a bigger slot in there. This whole thing just kind of bounce out because it was going east, and now it's either going northwest or west. You can see it was really start going this way. and then it'll slow down and come back this way. And all these vortices coming off it sometimes, like this one that whips around near the ground. Probably a pretty strong tornado. Why does every chase gotta be so wet? That's gonna do another big one right near me. Sick of the water. Look at that tornado. Look at the one that's about to happen. Oh my god. What happens usually with tornadoes when they die out is they die out back in the occluded area where the cold air and the totally chopped off from the good inflow, kind of left behind. Usually that's how it happens. Then this new area takes over and rotates around and does it again. But not in this case. The new area is over to the right, so this thing dies out almost in front of where it's gonna do a wedge. And it's just like the whole thing contorted around so much. And you also do get tornado out here, and it's interesting because a lot of these, when they have this big cut, because you can see that RFD notch cutting into the base right here, so that's gonna keep cutting around. It's trying to wrap this area up. But sometimes when they're real big and strong, the effect it has it can be an anticyclonic spin on the other side of that notch. So you can get this side, you can get anticyclonic tornadoes, though they're pretty rare. And it almost happens with this one because the tornado does happen out here, but I'm pretty sure the base was spinning cyclonically. But just on this side of the tornado, there's some anticyclonic flow. You can see that it'll kill it. It seems like it's killing it. It's like this area is trying to spin like it wants to, but then the whole push here is trying to make it go the other way. So it's trying to get a tornado, but then this is killing it this way. Look, it's just going to do another one right here. get ready for the next one. Crazy motion straight south. It's got to be about ready to do a big one back here. I hope it misses the town of Dupree. It should go south on the east side of Dupree. Hopefully that back one doesn't do nothing. The structure isn't real clean and perfect right here, but you can kind of see what happens. Kind of a real organized from this part forward, but this is a little weird. You can almost see what would be the RFD notch, the slot that comes in here, and it tries to do the little tornado here. But the big hole RFD notch is back here, so it's kind of having a problem. This front part will have a problem anyway. But you can see this part's cutting in here. Now watch in the next part. I'll show you the rest of this, how it's curled in. Not the clearest shot out the back tinted window, but anyway, the storm, you can see it's like the storm's got two cyclonic areas in it now, where this is the back one's going to wrap up a quick wedge. It kind of gets cold and undercut pretty quickly, but it's going to do that back here. And it's like on the other part, you have it's probably another cyclonic spin, but it's got a big RFD notch in the middle of the two. You got this and your main big RFD notch, and the other one wants to spin this way too. Often it'll be the other way if it's going to do it, but it actually, I think, does it the cyclonic way. And this main RFD notch kind of screws with that. You'll see in a second. I think it's going to tornado here and back there. Now watch what happens on this clip coming up here. We get the whole big supercell and the main cut back here, so you'd think this would spin this way, but it's clearly shaped like it's not going to spin that way. It's clearly got the notch coming around this way, and that is what's happening. It is cyclonic. It is spinning this way. So you can, but the thing to notice is watch this area. It's got to be spinning that way. Just the shape of it tells you that. And the tornadoes are wanting to spin that way. But watch these cloud tags here, the scud here. They're going that way. So you could tell there's from that push and that cut from the main area. This was trying to fire up and do the spin like it wants to, where the whole environment wanted to spin that way. But the storm environment's got that big cut in here, so it's kind of pushing back this way. You can see all that air is rushing this way in front of this tornado. So if you imagine this is trying to spin up, but that big area is pushing out this way, you can see if you get air finally pushing across here, it'll disrupt this. And you see it doesn't last very long. So that's exactly what's happening. That's going to go right into that town. I'll turn around. Oh no. That one is probably going to hit Dupree. This one scares the hell out of me here. That thing, 740. Oh, this thing looks anti-cyclonic right here. That thing is going to be going into Dupree now. It's fairly hard to explain the quote cold look to storms that they get unless you've seen at least quite a few, but this totally has the cold look to it now. We're just all raggedy and detached and just kind of got gaps all over. You know, it's not nice and flat. You know, it's not whole. It just looks like it's kind of garbagey. Pieces detached over here, and the main spin was in this part, but it's all getting so much cold air, it's just kind of stabilizing the whole area, and it's getting undercut. You see rain over here wrapped around. There's so much cold air now. The storm was sitting there for so long, raining and raining and raining. You get this really bad cold pool with the storm. It's really going to start to affect it now, where tornadoes don't last long. I mean, look how short that one didn't last long at all. And it's just getting garbagey and cold fast. Yeah, the problem with getting closer to that one is this whole deal right here. Now that I'm ahead of it, finally, the structure makes a little bit more sense again. Big round updraft base curling. I don't know if there's anything rain wrapped in there now. You can see how kind of straight right here and out here. It doesn't suggest there's a whole nice curl. Probably not. I don't think there probably was right now. The other thing that starts to happen is this base is getting pretty big now. It's getting pretty long. It goes from here and it keeps going over here. Way around there. They pass a certain size, you can tell they're just going to go high precipitation, supercell dominant, HP dominant, outflow driven mostly. When you have a big, intense storm with strong updrafts, and you also have good, strong venting shear loft, you're really drawing a lot of air in fast. And you can have your environmental winds picking up because of low pressures and all that. So you get your own environmental flow gets real strong, especially when the mixing from the loss of daytime heating first starts to end. You still got all that instability before it cools off, but it's not vertically mixing from direct sunlight, heat. So those low level winds start to ramp up, and you got your whole updraft taking in a bunch of air and getting sheared out. So that process by itself can draw in more and more air on its own. See, now after that's rotated further back in there, it kind of makes more sense. Have that big round area and your tornado would be back there. Because it was up here where that started. It's kind of in a weird, where it's kind of straight up front here yet. Just this interaction, this interface over here, or this inflow is coming around back in there, up in the hook notch area. Because your hook, the ball of your hook would be down here and all your precip's way up there. So the inflow notch is on the other side of this. You see that beaver tail-ish looking thing that was up there. But it makes a lot more sense now. But you can tell it looks cold in there now. where this all out here looked nice, but this is all broken up, junky, blue, cold looking. But it's a really big, mean storm now, as you'll see when this pan goes around. Just a big HP, high precipitation monster supercell right now, transitioning into a blob and then into a line. It gets harder and harder to do tornadoes, especially wrapped, good big tornadoes, because they want to be wrapped. That's how the structure works. Substantial ones want to end up in a coil, but if you wrap, there's so much cold air back there, it's just not lasting. It's not working out very well. And just because something gets really cold, outflow dominant underneath, still doesn't mean it can't have a tornado in there, obviously. Probably pretty likely it doesn't. Just how much cold air, just nasty slicing forward. But it really doesn't matter, because you don't need a tornado to have very, very high winds. You know, like you have a big area just spinning around up aloft and down here. Even if it's not a tight tornado or anything, it can still be really, really nasty, which I'm sure is the case, as you'll see if you watch this for very long. When I zoom in and just keep this shot, you can see everything just crazy fast slicing east, and then all the motion back here going this way. This storm is so amazing. Usually when you get this strong of outflow, just air in there that wants out, it's pushing so hard, usually it doesn't waste any time. It starts moving things along, or else just blast out and just undercuts this base. But as hard as it was wanting out, the air mass was wanting into this thing. Just the low-level winds were just forcing it in there. And this forcing itself out and this forcing itself in, you just had this crazy convergence. In the storm, even still, it's barely moved. It's still barely east of Dupree, just not even moving. How bright the camera wants to expose it. And you can see on that pan just how big this thing is getting now. It's kind of probably not even able to be a supercell anymore. It's getting just to be too big, too long, just kind of leaving the whole supercell category and entering complex or line, blob with some crazy shear into it. And the cold outflow really not wanting it to go east for whatever reason, just like it's getting forced to stay there just by strong low-level winds. surging east.